Good morning. Welcome to Civil with CRK. Today we'll try learn how to solve the truss using method of sections. Okay. So you have two methods to solve the trusses. One being the method of joints, the other one being method of sections. Okay. So we'll learn the method of sections today. Okay. Yeah, this is the question. Let's go through the question. Using the method of sections, compute the forces in members DF, FG, and GH. Yeah, these three member forces we want in the truss shown below. So you see DF is the top chord member, this one. FG is vertical member. GH is this bottom chord member. Okay, you need these three member forces. Okay, yeah, this is the given truss with 4 meters span each. Okay, and height of the truss is 9 meters. And the forces applied at B 800 Newton, at F 1200 Newton, and at E 2000 Newton. Yeah, so very first thing to do is to draw free body diagram of the truss. Okay, so for the entire truss we draw free body diagram, which means you remove this roller, apply the reaction, remove this hinge, apply the reactions. Yeah, so coming here, I'll try draw free body diagram. So here is a roller. One reaction is possible from the roller. Okay, here is a hinge. I remove the hinge. Two reactions are possible. One vertical, one horizontal. Okay, so name them. It's your choice to have any name for this, like R1, R2, R3, or vertical at A, vertical at H, horizontal at H. Okay, yeah, so this is what we named, right? So we need now these three unknown reactions to solve. Okay, yeah, now you see this is, if you treat this as a body, all these forces are of general case of force system. Okay, so they are not concurrent, they are not collinear, right? So you can apply three equilibrium equations for a body which is in equilibrium and which is under the action of general case of forces. So apply equilibrium equations. Okay, yeah, first I'll apply the first equilibrium equation, which is sigma fx 0. Okay, so this is sum of all x forces equal to 0 acting on this truss. So what are all horizontal forces are there on this truss? Okay, this is the only one force which have in horizontal direction. So horizontal reaction at H is equal to 0. Okay, this is the first equilibrium equation and the reaction value. So this we have got 0. Then apply the second equation. Sum of vertical forces is equal to 0. Okay, so treat any direction as positive, either upward or downward positive. So I consider here upward forces are positive. Now look for all vertical forces acting on this truss. So what are all vertical forces are there? See, from coming from left, VA is vertically upward, positive force. 800 at B downward, minus 800, coming to 2000 downward, and 1200 downward. Okay, then VH upward equal to 0. So we have taken all vertical forces acting on this truss. So now this gives you VA plus VH is equal to all these values, you just sum it up and take it to the right hand side, 4000. So this is the equation that you get for the equilibrium equation number 2, which is sigma Fy0. Then going for the third equilibrium equation, okay, which is obviously a moment equation, okay. So you need to apply total moments acting on this truss is equal to 0. So again, you pick the direction, either clockwise or anti-clockwise positive. Let us take clockwise positive. And the another thing that you need to do is choose the moment center. Okay. So in this truss, pick a moment center for taking moments of all these forces. Okay. Obviously, either A or H, because A has got one unknown value, H has got one unknown value here. So to eliminate that into the equation, we obviously pick moment center at A or H. So let us pick moment center at A. Okay. So choosing moment center at A. Okay. So now this will become sigma EMA is equal to 0 clockwise positive. Now write moments of all these forces equal to 0. Okay. So you are taking moments from A. Okay. So VA, that is a force, distance 0, perpendicular distance between this force and the point. Okay. The moment center exactly on the force. Okay. Yeah. Now coming to the 800 force. 800 into perpendicular distance from here to this line of action. Perpendicular distance from A is 4 meters. Yeah, the direction, you see the force is downward. So you see this lever arm, this imaginary line AC connecting the force and moment center. How it is being rotated? It is being rotated clockwise because this force will try rotate this line AC clockwise. We say clockwise positive, so I give plus sign here. Okay, coming to 2000 multiplied by, this is the line of action from A, perpendicular distance is 8 meters. Direction, again, line AE, how it is being rotated? Clockwise. So plus. Coming to 1200 Newton here. So 1200 into distance from A till this line of action, perpendicular distance is 12 meters. Okay. Direction, yeah, line AG is being rotated clockwise again. So plus, yeah, coming to the last force, which is VH, multiplied by the perpendicular distance from A to H, it is 16 meters. So now you see this arrow is upward. So upward force, how this line AH is being rotated anti-clockwise. So minus, which is equal to 0. Okay, so total moments acting on the truss with respect to A is equal to 0. Okay, now if you solve this, this becomes 0. We'll have VH alone. Okay, VH value is equal to 2100 Newton. Okay, so this is the value from the third equilibrium equation. Now substitute this into this equation, will give you VA value, okay, which is 1900 Newton. Okay, so this is how we solve for support reactions. Okay, yeah, so once you solve for support reactions, what next? Okay, yeah, method of section says to pass a section through the truss, okay, and see that the section shall pass through the truss, uh, cutting not more than three members or not more than three unknowns, okay, at a particular point of time. Okay, so for this section, you see, I need this member force, this member force, this member force. So I'll try cut this like this. Okay, so the members which you want, the forces in these members you want. So you try pass a section through those members, and the condition is see that the truss becomes two parts. Okay. Yeah, now we have a reaction here, we have a reaction here, okay, and we have got the values of 1900 Newton, this is 2100 Newton, okay, yeah. So this is how you choose a section and cut the truss into two parts. Sectioning means to cut, okay, yeah. So once you do that, now choose either left or right part of the truss. So here if you see the only way that you choose is the part which has got less number of forces. Okay. So now you see the right part has got less number of forces. So choose the right part of truss. Okay. So I choose right part of the truss. Yeah. Now I draw that right part alone. Okay. Yeah. This reaction you shall mention is 2100 Newton. Okay. Now you see here this member is cut into two parts. Okay. So represent the member force away from the section, which means you are assuming that this member force is tension. So this is FDF force, FDF. Same here also, this vertical member is cut. So from cut section, you mention or represent the force, okay, you represent the force away from the section, which means it is downward. It is FGF, okay, yeah. Now there is another member here which is cut, GH. So represent the force in this member as FGH. So these are the member forces or the reactions from the other part of the truss onto this part. Okay, that is how you should understand this, right? Yeah. Now the job is to find these the unknown forces by using the equilibrium of this right part. So consider equilibrium of right part. Okay, apply equilibrium equations. Okay, yeah. Now here you can use either force equilibrium equations or moment equilibrium equations, but always try to have as many moment equations as possible so that your solution will become simple. Okay, so I'll let you know how you do that. See, choose a moment center. See, we are trying to apply moment equilibrium equation. Okay, so I mostly use moment equilibrium equations wherever possible. Yeah, so now you look for a point where the two unknown forces are meeting. Okay, like this unknown force and this unknown force are meeting at F. This is possible. Yeah, this unknown force and this unknown force is are meeting at G. Yeah, this is possible. So these two are possible locations for keeping moment center. Okay, so let us first instance, let us keep moment at moment center at G. So my equilibrium equation will become sigma mg equal to 0. Any direction is positive, either clockwise or okay. Now take moments of all the forces acting on this part, right part, from G. Okay. So these forces are passing through G. So distances are not there. So moments cannot be developed by these two forces. Okay. Yeah. So then what are all forces? Even 1200 you see is passing through G. So this is also the force where moment is not possible. Okay. So the moment generating forces are only two, F, TF and 2100. So just try to formulate the equation. Force multiplied by perpendicular distance from moment center, G. So this perpendicular distance is given as 9 meters. You see the direction? This is the arrow. The perpendicular line, that is GF, how it is being rotated anti-clockwise. So I'll write minus. Okay. Yeah, 2100. Perpendicular distance from G is 4 meters. Okay, this GH span is 4 meters. And this also, the GH line is rotated by this force. This perpendicular is rotated anti-clockwise. So minus, put together equal to 0. So this will give me F dF value, which is equal to minus 933.3 Newton. So you got negative sign. The reason is you assumed it to be tension away from the section, the pulling force, but it is actually a compression. Okay, so that is what this means. Yeah, let us try find other forces also. Yeah, I said choose F as moment center. This first equation you are applying. Second, sigma m F is equal to 0. Yeah, any direction as positive, either clockwise or anti-clockwise. Yeah, let us try find moments of all the forces about F. Now you see 1200 is passing through F, FDF is passing through F, and also FGF is also passing through this F. So these three forces cannot generate moment. So what are the other forces which generate? GH and this 2100. These two will generate moment because they have got perpendicular distance from F. Okay. Yeah. Now write FGH is the force, horizontal force, perpendicular distance 9 meters. The direction you see from F, the FG line is being rotated clockwise by this arrow. Okay, that means plus clockwise. Yeah, now 2100 force multiplied by perpendicular distance from G till this force is 4 meters. Yeah, direction. This force here is trying to rotate this GH line anti-clockwise. Okay, it is minus. That's all. Only two forces generate moment. From this, we get value of FGH, okay, which is equal to 933.3 Newton positive, which means your assumed direction is correct. Means this member GH is in tension, okay, whereas DF is in compression, okay, tension. Yeah. Now let us find the third force. You see, to go for moment equilibrium equation, now I need this force. I need this force, okay, because I got DF value, GH value. I don't have a common point, meeting point for these two forces because they are parallel. Okay, so I can't use moment equation, right? So I shall go for, I have vertical unknown force, so I shall use Fy0 equation. Any direction as positive, upward or downward positive. Okay. Now write sum of all vertical forces on this right part is equal to 0. Okay. What all vertical forces are there here? 1200 applied force, FGH member force, and reaction 2100. Okay. Yeah. So 1200 is downward. I see negative. FGF is also downward. EF is also negative. 2100 is upward, positive, 0. Okay, so we have FGF force. FGF force is equal to 900 Newton, which is positive sign, which means it is also in tension. Okay, now if you just write the final solution, FDF value is 933.3 Newton, which is in compression. That is one value, and FGH is 933.3 Newton tension, and FGF value or FG, okay, 900 Newton tension. Okay, so this is how we solve the given truss with the method of sections. Okay, so if you want to represent the same in this diagram, okay, as member force, the FTF is compression, so I shall represent with two arrows pointing towards each other. The value is 933.3, whereas FGF is tension, so I shall represent the two arrows away from each other. Okay, pointing away from each. The value is 900 Newton. Okay, and the GH is also in tension, so I shall represent with the two arrows away from each. Value 933.3 Newton. So this is how you represent the forces in the truss. Okay, yeah. Hope we are able to solve and understand completely this method of